her now. So this is Nedra Albrecht, is it? And I'm really excited for her talk. I saw her speak 4 or 5 years ago. She's a data scientist. She does really cool stuff, and she's also a great presenter. So I hope you have a really good time. Thank you so much for being here.
Thank you. Hi, everyone. I'm really super excited you came to hear me talk today. I'm really passionate about data. I have been in the data space for over 20 years. I've actually never worked as a chemical engineer, but I find data very exciting. I think it is one of the things that is really changing and impacting our world. I think we all know that now. But the process of getting to that point was pretty lengthy over the last years. And I especially think that my chemical engineering background really helped me to really achieve a lot within my career. And I'll go through that later. But first, let me start by introducing myself a bit. Hold on, is it gonna go? Nope. Sorry, I'm getting ahead and it's bad. I don't wanna ruin the surprise. Sorry. So, is it gonna go? Okay, so my name is Nedra Albrecht and I'm married. I have 2 teenage daughters, 2 dogs, and 3 guinea pigs. My dogs' name are Penn and Teller. Yes, that Penn and Teller. And I love nothing more than to dress them in their little dog costumes and humiliate them. Some other fun facts about me. I have survived 72 apocalypses in my lifetime, according to Wikipedia. I experience grapheme synesthesia, which means I see words and letters and colors instead of black and white. This is what synesthesia looks like to me. And I can count to 10 in 8 different languages, of which I have indicated the flags here. I have a number of side interests like most tech people. I am a real estate junkie. I've done a number of real estate projects over the years. I've owned a few businesses, none of them successful. I'm also sort of this armchair philosopher. I like understanding why things are the way they are, and I'm also really fascinated by language. I'm also a huge dubstep enthusiast. So I did graduate from the ChemE program here at UW in 1998. And what I think was most interesting about my program at the time is that we were 50% women in that class. And when we graduated, it was 50% women, which is unusual even for now. I met my best friend at the time. Her name's Jenny. She and I, this is us on graduation night in 1998, and us last month on a trip to the North Cascades Highway. Jenny is now a high school calculus teacher by way of being a nuclear engineer for a number of years. And I remember 3 things about this program. I remember that Avogadro's number, 6.02 times 10 to the 23rd. I will never forget that. I also learned mass is a closed system, as in when I tell my kids you've lost something, mass is a closed system. Mass is neither created or destroyed, it's only rearranged, so it can't possibly have gone away, it's gotta be around here somewhere. And everything I'm learning now doesn't apply to the future, which I understand why they said that, but I don't agree. I think I took a lot of the things from this program into my future. Speaking of which, I alluded to the fact that I've never worked as a chemical engineer. I actually sort of fell into programming back in there wasn't a lot of comp sci people. It was a relatively new major. I was here in Seattle. I didn't know what I wanted to do with my life. I was working at a place and they said, can you do a database? And I said, sure, of course I can. I knew nothing. I kind of taught myself Access 97 and it went from there. I started really enjoying coding, learning more about it, worked at a .com until it .bombed. Then I started working at this place called Vertifor. They're an insurance software company, and this is really where my story with data begins. The rest of my career is just working with these different types of data. These systems, this is kind of like the way that the data is structured: transactional, reporting, NoSQL, and big data. I'll go through what all of those mean during the course of this presentation, but I have worked in all of them. And currently I am at Slack. I was at Zillow until very recently, but I've just joined the Slack team. So that's enough about me. Let's talk about the fun stuff. Let's talk about data. As I was preparing for this speech, I presented it to my oldest and she said to me, Mom, this is great, but I still have no idea what data is. And it got me to thinking, we all know data exists. We hear about it in the news, we deal with it all the time, but I don't think most people understand how the tech industry uses, views, and works with data. So today I'm going to try to illuminate that a little bit. But I'm going to start by defining data. What is data? Well, here is the Webster's dictionary definition, and it is in fact accurate, clinically accurate. And I really don't think it captures the feel of what data really is. So I actually titled this speech, Data is the New Oil. And that's true. People do say data is the new oil, in that it is, creating a new economy like oil did. It requires some sort of distillation or processing in order to make it useful. But I still don't think this adequately captures what data is. To me, data is language. Language is the system that humans use to describe, quantify, and communicate information, much like data is the system that software uses to describe, quantify, and communicate information. Both systems are used to communicate between individuals and groups of individuals. Both systems really have rules that govern that communication, and there's many different ways to communicate, not just one. Both language and data evolve according to the underlying systems, and both of them have lexicons or vocabularies that people use to describe other information. So if I wanted to put it a different way, language and data is the software that runs on this hardware. So I've talked a little bit about what data is, but now let's talk about how that data is really part of our everyday lives. We are immersed in data more so now than ever in history. When I talk about that, I think people know intuitively what that means, but here, let me kind of give you a feeling for what that means. We wake up in our day and we get on our devices or our computers and we talk to our friends and family and colleagues, and we get on social media and figure out what's going on, and we do things that make us productive or search for things, or we buy things or manage our bank accounts, or we go shopping and have stuff delivered to us, or we eat or go out and get groceries. We entertain ourselves in multiple ways. We go places and do things. We track our health to make sure we're doing okay. We use products that help ease our life. And we're very helpfully noting in space and time when all of this is occurring through our telemetry data, which your phone is always collecting. It can't be turned off. Now, these systems obviously are data, but these systems were built using other data, like governmental data or weather data or satellite data, health data, demographic data. All of this data goes into making data, but that's not it. There's the data we generate directly. There is the data we interact with. So like you go on a web page, you see all this stuff and you buy something. In addition to that though, there's data passively collected about what you do. It's called clickstream data. So everything you click on or don't click on, that's all recorded. And then there's data that the software programs use to communicate with each other. Again, data is about this communication. So they also send off messages to say, like, if the server's down, and we can, check to see how things are going. And this is my favorite kind of data about data, which is called metadata. And it's actually quite powerful for automation and other things. So it's not just the data that you think about, it's the data ecosystem that supports that. So I'd like to point out something that's practically cliche at this point, but you are the data that you produce. And this is kind of how it works. Let's pretend I'm a data engineer. I'm actually a data engineer, not a data scientist. And I will describe why those are different here in a little bit. But if I was to model you as a person, like if I was going to model this table, I'm like, it has a size, it has a number of legs, it has finish, it has all these details that describe it. So if I were to describe you, I would want to know your demographic information, like your age, your educational level. I want to know your preferences. What do you like? What do you not like? I want to know your social information, your social media information, which we all know why now they want that. But I'd also want to know your relationships, and not just your immediate contacts, but like who you've done business with, how long you've done business with them. And I'd want to know your device information, which is actually always available to anyone who wants to get that information. And I'd want to know, like, what did you do? What did you click on? What didn't you click on? And I'd want to know, like, what you bought and where you bought it from and who you bought it from. And I'd want to know your location and where you were and how long it took you to get there. And I'd also, of course, want to know your PII, your personally identifiable information. Well, when people talk about data privacy and data security, when they're talking about that, they are only talking about PII. They are not talking about this data over here at all. This data has been anonymized in such a way that you can disconnect your name and address from your behavior patterns. But the thing is, I don't need that. I've already built you out of all these data points. If you think about it this way, I am exactly 2 points of identification away from knowing that I'm the only Nedra Albrecht that works at Slack. So you only need two data points to really construct me as a unique individual. You didn't even need to know my name. So that's kind of what's going on here. So each person is sort of like a unique fingerprint in the data without even your name. And that's okay. Great. So why is this valuable? I mean, obviously, we know people are making money off of it. They're using it to get our attention, and they are using it to influence us now. But you're you. And I just said you're a unique fingerprint. How could there possibly be this situation where we can create this? And really, it's because you're you, and you're you. And eventually, if I get enough yous, patterns start emerging. And if you come in and you exhibit the characteristics of this one person, I can provide recommendations for you based on that. Or if you show these characteristics, I can infer other characteristics about you. This is the entire field of ML and AI. And I could talk for 2 hours about this subject, but I don't have time. So we're going to move on. But, I'd like to talk now about how data sort of comes to being, right? In the tech world, data just doesn't happen, right? Like we have to do something to make it happen. And tech companies kind of all follow this similar pattern. And this is, I guess, this is a glittering generality. Not all companies generate data this way, but here's an illustration. So the way it works, you have a couple founders. They're like, I have this great idea. I'm going to go out there and it's going to be amazing. And so they check with the biz dev people or their VC capitalists. They're like, yeah, is this a good idea? And then these people are like, sounds good to me. And the founders are like, we are going to make some money. So they hire some project managers and some software engineers. And that project manager kind of collaborates with those software engineers. And they come out with a product, usually an application or a website and a database. The little sausage looking thing, that's the symbol for a database. And I had mentioned before, we collect data, but we don't just collect data about the immediate interaction with that app, we collect all this other data as well. And so the business says, this is fantastic, but what did they do? And how many people came? And what did they spend? And what did they buy? And I want to answer all these questions. And they go back to this database here, and they're confused. And largely that's, largely that's because this database is structured to talk to other software and machines. It's not structured to talk to people. The data models, and I'll talk about that later, really are suited towards this optimized problem of software. So instead, tech companies have added this layer of data engineering. They are responsible for translating this machine structured data to human understandable data. And that's called analytical data. It's often called a data warehouse or a data lake, lots of different terms. It's really not important. But what is important here is that in addition to having this semi-readable or human understandable data, these data scientists create reports, answer business questions, but they also look for other patterns in this data. This is small scale data, not big data. Oops. Oh. And they've added this new layer for big data, which is called machine learning engineers. And these machine learning engineers, they look for these patterns in the data and they either report on it or feed it back into the system and they create algorithms that work on it. But that is generally how tech companies are laid out when it comes to data. That makes the business very happy. Our business is very successful. And the executives have achieved the dream that everyone in tech has, is that they're rich and they have a lot of stock. But we didn't get to this point today without having a lot of change to get to this point. Data scientists, data engineers, and machine learning engineers are relatively new in this field. And like in the last 7-10 years at most, right? So what came before that? Well, let's talk about that. But first, I love this movie, The Matrix. I'm sure lots and lots of people do. And I think it's hilarious when Morpheus says, we marveled at our own magnificence as we gave birth to AI. Well, no offense to Morpheus, but we did not give birth to AI. We gave birth to big data, and big data has given birth to AI. You can't have one without the other. AI functions entirely on top of data. This is going to be the story now of all the different kinds of data models that I have used over the course of my career. But let's start at the beginning. So before the internet, 1962, we lived in caves. We talked to people. If that person wasn't there, you couldn't talk to them. It was crazy. We used paper maps for like going out and like navigating. It was insane. But fortunately, I was born after that. I did not have to live in a cave. But there's this sort of period of time from when the internet was invented to when it started to become more adopted. And that was roughly in the year 2000. I'm going to pause a moment and talk a little bit about the amount of data created in the world. So this chart is going to be about the amount of data created in the world that year, not the total amount of data. And it's always measured in zettabytes. So what's a zettabyte? Humans aren't really great at big numbers, so I'll just kind of walk you through what this means. It's 1 trillion gigabytes. And we all know what a gigabyte is, and a trillion's a lot, okay? But that's still not super helpful. And we're all engineers, and we love a good chart. So here we go. This is what it looks like. It's a logarithmic scale, so pay attention to that. And we're really familiar with these kind of sizes of files. A terabyte, you probably have a terabyte drive or 1 or 2, but if you add up all the apps in the Apple Store or all the songs in the Spotify catalog, you're looking at a few hundred terabytes worth of data. So that kind of gives you an idea what we're talking about. Facebook generates around 5 petabytes of data, probably more so now. And most medium-sized companies have petabyte scale data. However, the big tech companies have over exabytes of data, Google, Facebook, Amazon, and Microsoft, and I would guess that AWS is in the hundreds of exabytes. And this is the unit of measure we're talking about, okay? And that was all cumulative, what I just did there, but we're going back to whole, it's just the amount of data created by the world. So year 2000, I guess most of you probably were born about that time. I started my data career at this point, and there was 0.01 zettabytes of data created that year. And generally at that time, the problem that tech was trying to solve is this idea of transactions. And let me illustrate that. You have an app or a website, it goes over the internet, and then it lands in a database. And the point is that it's a bidirectional communication. You can get information back out, you can alter it, delete it, whatever. Reporting generally at that point in time was against this database directly. So it was great. We could add, update, delete this information very rapidly, especially when you had very large data sets, but it was terrible for reporting. You had to know the model. You could very easily make mistakes. It was very intensive to create the queries. So they switched it up. And they started with this thing called dimensional modeling, which is just an extension of this transactional modeling. We're still doing this, but we've now added this new layer. This is called the data warehouse that I had mentioned before. And essentially this layer is a way to abstract or separate the concerns of the database from the analytical needs. The process of going from the database to the data warehouse is called ETL, which is called extract, transform, and load. It's just a way of moving data, but it is heavily prominent in the industry. We still write reporting, but we put it against the data warehouse now instead of the database. So it's great. It's good for ad hoc reporting and ad hoc data exploration. But then the problem became there is like a bottleneck now in terms of staffing resources to do this conversion because it's quite laborious, as well as the data size. Sometimes we would process data that would take more than 24 hours. If it takes more than 24 hours to process the days of data, you're never going to catch up. So they had to kind of shake things up a bit. So let's look where we are in terms of data size at this point in time. In 2010, we're at 1.2 zettabytes of data. But at this point in time, Facebook was created in 2004, YouTube in 2005, Twitter 2006, and Netflix streaming and the iPhone came out in 2007. And what they realized were that these two data models weren't enough to fill their needs for the business. So they really did a lot of work in this area during this time frame, about 2005 to 2012. So let's talk about what they came up with. It's called NoSQL. It is not NoSQL, the language SQL. It's just type of data modeling. And it's just, all it means is flexible data models, and there's a bajillion of them. So I'm not even going to get into those specifically, but really the idea being you have the same setup, but then this data layer has both this transactional process as well as this NoSQL process. That data can be updated, not updated. That's not really the point. It's just that it's more flexible than before. We still have this sort of separation of concerns, but instead we just copy that source data all the time. And because the data warehouse continues to be the bottleneck, we created new tooling that would allow people to just directly query that source data. There was a lot of change sort of that we're now experiencing that started during that period of time. So this is great. It's more flexible, the business is happy, they can get what they need. But the problem is it can be extremely hard to translate that into something that is actionable for the business to use. So let's talk a little bit about this like data growing. This is now the point in time where all of these models that we currently have, and I'm not talking about ML models, I'm talking about data structure models, are now working together. And the data size starts growing fairly rapidly. And this is good. But the problem is we kept growing. Well, I don't know if that's a problem. That's not really a problem. It's a good thing. But we just kept replicating this concept and replicating this concept. And we had so much data, we didn't know what to do. So we used that ETL to collect all that data in a single place called the data lake. It's called the data lake for a lot of reasons. I'm not going to go into it. And generally, it's called Hadoop as well. But this is the layer then that the reporting is pointed against. We're still having those additional tools. We still have the data warehouse, but this data lake concept exists. And why do we have that? Well, it's really good for creating a single source of truth. This is one of the struggles in data. How do I know that this piece of data is the correct piece of data? Because sometimes you get that data from 5 or 6 different sources and different rules. And so what you do is you take these 3 systems and then try to conform them. It's called conforming the data. And really, you're trying to create this singular model that sort of gives everyone who wants to think about this thing a definition that is unchangeable, or it's called vetted. So really, everyone uses and trusts this model of the data, even if there's copies made. So this becomes the source of truth. But where it becomes a problem is, like I said, matching can be very challenging. I'm not going to get into the why, but there's a lot of technical challenges to that. So we finally get to big data. And what is big data? Well, big data is the same thing as everything else, just big. We now have this giant data lake, and it's so big that ETL, again, is the bottleneck. So instead, they've created something called a messaging system or messaging queues, and they just pump that data directly into the database or into the data lake so that people can then just start their reporting against that, just like before. But what changed is this. Because some companies have this vast amount of data, they can then take that data, apply these AI and machine learning models, with that training data and create this model, which is then plugged into a system that influences the system that you're using. So it becomes this circular loop of feedback. I've emphasized this enough and I want to emphasize it again. Big data requires, AI and ML require vast amounts of data. If you think about it like this, my favorite was color is black, and so is yours, and so is yours, and that was our entire data set, your data set would look like everyone in the world's favorite color was black. That is an incorrect assumption, right? So people have to be very careful to not make the wrong conclusions based on these patterns, and regular size data will not work. So here's where I think it gets really exciting. So in 2015 is when I switched to big data full time. In 2017, I gave this speech, a version of this speech before, and it was 23 zettabytes. Predicted, it wasn't, that 2017 hadn't completed yet. I gave the prediction for 2020 at the time as 44 zettabytes. That's a lot of data. But what happened? Like, was this true? Was this too high, too low? I don't know. So I managed to actually correctly graph this to scale. And we're here. We actually had 15 more zettabytes data created in 2020. I doubt they saw the pandemic coming, which I'm sure influenced that, but we're on track to 79 zettabytes and a whopping 180 zettabytes by 2025. This is mind-blowing to me. I feel like things are changing very quickly. And this is an exponential curve. So many things in software, it's almost ludicrous at this point. Everything's on an exponential curve, and we're sitting right there on almost all of them. So what's next? That's an excellent question. I have no idea. I have some ideas. These are things that I'm interested in. This data mesh concept I'm working on at work. I'm interested in the distributed data concepts. There's other stuff coming. But here's one thing I do know, and I'm 100% sure of this. Whatever happens is going to happen very fast. You guys were born kind of when this started. And if you can, I can feel like my career accelerating, like the things that I need to do and the things that the changes that we're making is accelerating. But I think that's applying to our whole world, not just software and data. And I think the next 10 years are going to be just crazy. And that's kind of saying something considering last 5-7 years, right? So that's kind of the story of how I have moved through my career. But let's talk a little bit more in depth about these particular career paths you can follow when you're coming, if you want to participate in the data world, so to speak. But really, all of these positions deal with data. As I had mentioned, the SDEs, they create data and they work to create systems that will create and response data. Data engineers do that translation piece I talked about. Data scientists work on analyzing the business needs. And then MLEs are looking at sort of the signal in the noise, the mathematical rigor applied to data. So if you're working in this quadrant, you are going to be mainly structuring your data for software consumption versus humans. And if you're in this quadrant, you're generally going to be working on data production and the tooling and systems that support that versus exploration and consumption. But really, all of these positions are needed in order to make a full picture about what data is. Generally, well, over the years, it didn't used to always be this way, but over the years, tooling and languages and things that the different roles use has converged. So now mostly, if you wanted to get into this work, you would learn Python, SQL for sure, and not so much the compiled languages. The SDEs really have this compiled language that they use, and I'm not talking about web devs, totally different thing. But then there's also this language called Scala, which is a type of programming called functional programming. It's very suited towards processing data. And so a lot of DEs and MLEs use that as well. All of them have experience with databases, but different kinds of databases. RDBMS is that database that does the transactional and the relational. Hadoop is the one with the data lake, and NoSQL lives in Hadoop or other, there's a variety of things that happen there. So practically speaking, what does my life look like? Well, this is what it looks like. I sit at my desk 8 to 15 hours a day, 5 to 7 days a week, looking at 1 to 4 screens, doing my job and typing. That's what I do. And I also have to deliberately update my skill sets every 5 to 7 years, or I'll age out of this profession. And what that means is, if you notice, this technology changes, and if you're not up to date with that current technology, even if it's wildly different than before, you won't get the kind of career progression that you would want. It happens quite a bit. And also, I work with really smart people doing some pretty smart stuff, and it can be a lot of pressure. There's a lot of money involved. And then also, I often feel like the village idiot coming into the room all the time because these people are very smart. It's a pretty challenging career path. So why do I do it? Like, why am I this glutton for this punishment? Well, the first reason is I have ultimate job security. Data hasn't always been the most popular kid in the room, but now it is. And DEs are vanishingly rare compared to SDEs. They're like for every 100 SDEs, there's like 1 data engineer. And most of them are relatively new, so they don't have a lot of experience with data. And demand is greater than ever. And this work spans all industries. So if something happened to tech, I can move into any industry I wanted to. I also make good money. I'll be honest, I don't have to worry about a lot of things. I support my whole family as a single earner. And that's pretty unusual these days. But here's really why I do it. Because I work with really smart people doing some pretty smart stuff. And I'm working on things that are at the bleeding edge of technology. I get to work with data that affects tens of millions or hundreds of millions of people at a time. And the things that I do directly impact so many people's lives. It's not all, dystopian craziness like I kind of made it seem like. Data is pretty benign. It's the algorithms that are really the problem, but it is an exciting field to be in. So I started the talk saying that I think chemical engineers are better suited to data than ChemE. And here's why. ChemE, they teach them the SDE skills. SDE skills are different than data skills in that generally, again, broad brush, they're working on optimization. They're working on making it as fast as possible. And their way of approaching systems is much different. Chemical engineers, on the other hand, have a lot of skills that you guys come out of school with already that are super applicable. For instance, you have extremely advanced math skills. I know that because I did this. And really, like, machine learning sits at this intersection of statistics, linear algebra, and multivariate calculus. And most ChemE people do not go to the level of calculus that you guys do. Also, this sort of engineering mindset that's built into ChemE that's not necessarily there in ChemE. Again, it's a different focus, a different purpose. But really, that kind of manifests itself in this second order thinking that you guys have, or multi-order thinking. And what that means is you have a system, you make a change somewhere in that system, and then it propagates through that system. You look for how that will affect that system. So that is the kind of concept there. And I think that's super important. You're also experienced with analyzing scientific data, drawing conclusions from that, and then making and validating assumptions. So basically you set up experiments and you see how it goes. And that's pretty common in the tech industry. And this one I think is also really important. You're experienced with systems that have a time component. Data created today is much more valuable than data created yesterday or a week ago or a month ago. And as time goes on, that data becomes less valuable in certain circumstances. So having this awareness of how time impacts systems is a valuable skill. And lastly, process engineering is really ETL. It's the same thing, except with chemicals instead of data. Like, remember I said you take data, you do something to it in the middle, and then out comes something? That's the same thing. So we've reached the end of this journey today. Thank you for listening. I really appreciate it. I absolutely love sharing and talking about data. I'll talk your ear off for hours about it. And I've shown you a lot of things, and hopefully this has helped giving you an idea of what it's like to work in the data space, kind of the careers you can choose, how data impacts you, maybe gives you a little bit more tangible idea of how we got to the state we're in now. Feel free to LinkedIn me, ask any questions that you want if you don't get them answered today, and I will take any questions now. Thank you. Any questions? Yeah, go ahead.
You mentioned aging out 5 to 7 years without updating skills.
Yeah.
I guess it's kind of hard to say this because, like you said, it seems like things that exponentially change. Do you think it's foreseeable that someone could maintain a career in this room for years? In the next 4 years, you can just
Yeah.
about the skill sets that they
Yeah. Yeah, you just have to be mindful of it. You also have to be very, oh, sorry. So the question was, can you repeat the question? Here, I'll come closer. Here, there.
With how developing the industry is and how necessary it is to develop new skills during the career, is it feasible to maintain a long-term career in the industry?
Okay, long-term career in the industry. Yes, I do. Even now, starting now, I think you can still maintain that. You just have to be, deliberate, right? You have to push yourself constantly. There isn't a time when I can say, yeah, I don't feel like learning that, right? And eventually you get into this habit. It's not like, it's like you're studying like you're in college all the time, but you can't go 2 years and say, oh, I'm comfortable with what I'm doing. I just want to keep doing this forever, because that's really where I see a lot of engineers. They'll be comfortable in what they're doing and they do it well. And the new stuff is scary and you have to start over and you're junior effectively. And it's kind of an ego blow. You have to really, think about it. So, yeah.
I was wondering, you mentioned a little bit like that, but like, what is wrong with that? Like where is the danger?
Oh, yeah. Okay, the question is, and correct me if I'm wrong, what's the danger of having your data in public? Like why is that an issue? It depends on the data, right? If it's your PII, which would be like your name, address, account numbers, so social security card, it's mostly about identity theft, and then like social engineering, hacking. There's not necessarily a problem with it. Like I said, data is fairly benign, but where it gets to be a problem is when we try to predict or influence what people are doing based on these data patterns that we're seeing. I mean, like in my example of like favorite color, like if we are making the incorrect assumptions and we don't even fully understand how these machine learning algorithms manifest themselves, then it's a problem. But yeah, like identity theft is something different than this other stuff. So, yeah.
So sort of springboarding off an earlier question, when you're updating your skill set like that, what does the process look like? Like, do you take a class? Do you just start independently doing the research and doing your own projects? What do you do to update those skills?
I get a new job doing that thing. I mean, I know a lot of people will like read a book or take a class or whatever. I learn best by doing. So honestly, I just kept getting jobs that helped me learn those skills a little at a time. And so by making those job transitions, I just learned it naturally because of that. I'd always volunteer to take on the latest work and, things like that. So. Oh, and I forgot to answer that, say that question out loud again. That question was, how do you update your skill sets over time? So, anything else? Yeah. Okay, so what is my most recent project that I've worked on, or what does a project look like for me? It depends on the position. The position I'm at now at Slack is it's in their data modeling and architecture group. So right now I'm looking at creating metrics, which is just like a fancy way of saying reporting. Metrics based on some of their latest data. But other responsibilities I have are looking for ways to optimize the system, looking for ways to improve our processing. So it's kind of open-ended. I do have responsibilities, but the expectation is that I'll have these sort of lateral responsibilities to help it grow. Within software, there's sort of like a hierarchy of positions. You come in as junior, you're just learning, you kind of move up to mid-level, then senior, and then principal, and there's other ones in there. But in each of these positions, you have like a certain expectation about what you'll produce. So like at the principal level, they are doing things like overseeing projects that span multiple groups, multiple teams, possibly even multiple organizations within the company. So it's just really a matter of scope of responsibility as you go. Yeah. The question is, how did I get a job in data instead of chemical engineering? So when I graduated, there weren't a lot of ChemE jobs in the Seattle area. I actually moved here from Oklahoma and I loved it. I fell in love with the city. I didn't want to leave. And I wanted to go into drug manufacturing, and I didn't want to move to New Jersey. So I was just sort of hanging out, and then I sort of fell into it because at the time it was hilarious back in the day. Like nobody had comp sci degrees really. It was very rare. But everyone was kind of self-taught. It's very much the inverse now. And people, like companies would drive buses around downtown Seattle and be like, do you want a job? Do you want a job? And they have like kegs in the back and they just pull people in and give them jobs if you knew anything about computers at all. It was crazy. Well, if you were a guy. If you were a girl, that was not the experience you had, but if you were a guy, that's how you get it. So, so what, I just sort of like, that's how I just decided I liked it. And I was like, I don't care that men don't want me to work here. I'm going to do it anyways. Because in the 90s, that's how it was. You didn't care. You just did it anyways. So, anybody else? Yeah.
How did you deal with that discrimination?
How did I deal with that discrimination? Force of will. Honestly, I wasn't going to be defeated. I grew up in the South, and I was absolutely not going to have any of that crap from anybody, so I just didn't. I stood up for myself. I mean, I went on, early in my career, I went on hundreds of interviews. It was miserable, and I have no idea why I kept going, other than the fact that I found data so interesting that I knew if I didn't do it, I'd be like really unhappy. So, yeah. Anybody else? Yeah, go ahead.
So compared to those times, how much would you say it has improved?
Okay, compared to early 2000s, yeah, how has it changed?
From 1 to 10?
I would say we're at like a 6 or a 7 now. It's much, much better. Okay, I will say it is much better at some companies. It is not better at all companies. I'm very careful about who I work for, very careful, because it is very easy to get marginalized still. But generally, I find like the real good tech companies, the big names, they do decent. I don't feel like, maybe there's, like hidden agendas or whatever, but I find that if you just do your job well, that's enough. So. Anyone else? Oh, yeah, I'll go with you first. Okay, so I work a lot of hours, and what does my work-life balance look like? Again, it depends on the company, and it's kind of like a cyclical thing, right? You'll go through projects where everything's like all of a sudden it needs to be done by this certain deadline, so you work a lot of hours and then it kind of tapers off. My work-life balance at Slack is actually really, 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 really good. I'm down to just about 40 hours a week, which is amazing, and it's low pressure. But I don't know. Did I answer your question? I was like kind of trailing off in my head there. So yeah. Yes. Yeah. Oh, okay.
No, they're just me saying, "We have a question." Thank you. Yeah, I was like,
doing sound check, that's all of that.
Are a lot of the data science and engineering jobs still remote, or are they home back to the office?
They are still remote. I'm actually full remote. Slack's based out of San Francisco. I don't think it'll last. I don't. I actually worked from home for about 7 years when my kids were young, because young children, parenting, coding jobs, not so much. So I took a step back in my career at that point. And what happened was my tech skills were sussed, because a lot of technology is learned by just like watching other people or talking to them, or like these sidebar conversations, or getting up on a whiteboard, which we don't do anymore because of COVID. I think that people are going to realize that, and we'll have more back in the office sort of situations eventually. I'm going to enjoy it while I can, though. Anything else? Thank you. Oh, we're like perfectly on time. Wow, when I practiced this, I was like, I'm gonna be up there till, like, I seriously could talk about this for days. So cool, awesome. Well, thank you guys so much.